Definitely the wickedest thing I've ever in my life.
Hello, I am Professor Moran, and this is my colleague, Priscilla Chu. Today we will be discussing the physics behind ballet. We have decided upon 3 principles that govern the scientific truths behind this beautiful art: momentum, Newton's third law, and circular motion.
In order to help demonstrate these principles, we have called upon an aspiring dancer, Megan. Megan is with us here today. Now, Megan, how many years have you been dancing?
14 years.
Wow. And what are the constant struggles you face as a ballerina?
Well, for me and many of my colleagues, I would say the occasional injury always threatens a successful dancing career.
Do you have any current injuries right now?
At this point in time, my MCL tendon in my knee is slightly torn due to a kneecap dislocation that happened about a month back.
Thank you.
You're welcome.
We've researched Megan's injury extensively and come to the conclusion that she's neglected the basic principles of momentum.
And through neglecting these principles of momentum, Megan has injured her MCL tendon, which was mentioned before. Now, momentum is the direct relationship between mass and velocity. Another aspect of momentum which must be taken into consideration is impulse, which is a change of momentum. And the equation for impulse is equal to force times the change in time. Now, in Megan's scenario, she failed to lengthen time to decrease the force upon a dancer's body,
thus resulting in an injury. Not only does physics have the ability to prevent an injury, but it can also enhance the dancer's ability.
This leads into the positive applications of Newton's third law, which states that when an object exerts a force onto a second object, the second object exerts the same force onto the first object, equal in magnitude but opposite in direction.
In ballet, we look at the common step, the sauté, which is a jump off 1 or 2 feet, and ends with the plie, which is a slight bend of the knees.
After some extensive experimentation, we have discovered that a greater plie results in a greater distance off the ground.
Wow! Physics fixes everything!
Megan begins to gain more and more distance from the ground as she focuses on deepening her plie.
Megan is exerting a force upon the ground, and in return the ground exerts a force on her. As one of the most profound physics professors said, Kirk Davis, forces come in pairs.
Thus, Megan is able to achieve maximum height by applying Newton's third law.
Another principle of ballet we chose to focus on is called the fouette, a simple ballet turn.
Now, the fouette depends primarily on rotational inertia, which states that an object that is rotating will remain rotating and an object that rests will remain at rest. Rotational inertia depends primarily on the distribution of mass. For example, the greater the distance the majority of the mass is away from the axes, the greater rotational inertia it has.
When a dancer fully extends her arms, she elongates her mass away from the axis, creating more rotational inertia.
Likewise, when a dancer brings her arms to her chest, her rotational inertia decreases, thus spinning faster. This is applicable to the fouette. As Megan demonstrates, she is rotating faster in the closed position.
Using rotational inertia as a principle, it can aid a dancer in her turns.
I hope you learned more about the relationship between physics and ballet.
Thank you for watching.